In this video, we are not just going to memorize the derivative rules. We are going to learn something even more important, that how do we actually know which derivative rule to use when? Because a lot of students that I've noticed know what is a power rule, what is product rule, or pretty much any other rule. But whenever they see a mixed question, they get stuck on it. So today we are going to learn how to recognize the structure of a question before solving it, and then in the end of this video you should be able to say that whatever the question is, you can solve it with a particular rule. So before we even dive into these kind of things, I want to go through some derivative checklists so we know which one to do when. So it's like placing a strategy right now. So if you guys see a single term called x of n, then you just simply know that it is the simple power rule, which is like power drop, power 1 less, which is n minus 1 x n minus 1. So power drop, power 1 less. Sorry, it's gonna be power drop, power 1 less. Let me do this one more time. So we say whatever the exponent is, you drop it, and then you subtract 1 from it. And this is called the power rule. The other one being something is being multiplied by something. And whenever you see two of the functions being multiplied or two separate things being multiplied, you apply the product rule. What are these rules? We'll see them respectively when we are solving these questions. The other thing can be something being divided by something, or in other words, there's a function on top and there's a function on bottom and they're being divided. So you use quotient rule to solve these things. Another one is something inside another function, or in other words, there's an outside function and within that outside function there's an inside function. So in those kind of things you use a chain rule. And last but not least, more than one pattern, which is like applying 1, 2, 3, 4, whatever it takes by the judgment of the eye. So just to look at all of these questions, let's start with the easiest one, which is being power rule. So as mentioned before, still power rule is you drop the exponent and then you subtract 1 from it. So if it's like x of n, you say n, x n minus 1. Let's just do a quick example of this. You see 7, you ignore 7 for now, and then you're left with x cubed. So in x cubed, the cube is the exponent. So you just drop the exponent and subtract 1 from it. 3 minus 1 is 2. And in the end, you'll be left with 7 times 3, 21, x squared. Similarly, if you do this, the only difference is I just put a root on it. You can just make it x1 over 2. And then if you just start to take a differentiation on this one, or take a derivative of this thing, you'll notice exponent drop and then exponent 1 less, 1 over 2 minus 1, which then becomes 1 over 2 x minus 1 over 2, or in other words, it's going to be 1 over 2 root x. Pretty simple. Power rule is the easiest out of all of those rules. Or I spoke too soon, because constant rule is another rule which is easy. The constant rule is, since we are all taking some derivatives on the x, but in this one you start to notice that there is no x. Like in this whole thing, there is no x. So whenever there is no x, it's a constant, and the constant differentiation is always equal to 0. Just look, for example, if we look in this question, we see two terms, 4x squared minus 9. So let's differentiate it. The 4x squared would be 4 stays the same. X squared is the power rule from the top, so you just say 2 drops in, and then 2 minus 1 will give me 1. So I leave it like that. Whereas minus 9, the differentiation of minus 9, since minus 9 is a constant, is going to be 0. And in the end, we're going to be left with 8x plus 0, which is indeed 8x. The other one is the constant multiple rule, which I already covered here, but let's just be more specific. You will see a lot of times there's a constant attached to a multiple, just like 5 here, minus 3 here. So as I mentioned before, you got to repeat it. You just leave the constant as it is. You don't touch it at all. So I'm just going to ignore 5 for now. And then I see it's x4. It's a power rule. So you just say 4 drops, and it's going to be 4 minus 1, which is 3. And the answer for this one is 20x cubed. Similarly on this one, you say minus 3 stays as it is. Now x6. So 6 drops, and x becomes exponent of 6 minus 1, which is 5. So your answer is minus 18x5. Similarly, we can combine all of this and give you an expression which has multiple things from A, B, and C, which is pretty easy. You just look at each of the things one by one. You first take care of x4, then you take care of this, then you take care of this, and then finally the constant itself. So if you start solving this one by one, we see x4 becomes 4, x4 minus 1, which is 3. And then the other thing becomes 3 stays the same, x squared, the 2 drops in, which makes it 2x, 2 minus 1 is just x. And similarly, minus 7 stays as it is. And then the exponent on top of x, which is 1, drops in. So it's going to be 1. And x1 minus 1, now notice this, x1 minus 1 gives you x0. And anything raised to the exponent 0 is 1. So that's why you just say it's 1. And then the constant is just 0. So now if you just further simplify, you start to notice it's 4x cubed plus 6x minus 7. That's it. The other thing is a product rule. Now, this one we see there's one function and there's another function. So in these kind of questions, you have a function f and a function g. No matter what these functions are, the rule remains the same. The rule says the answer for this one, the derivative of fx gx, is f dash g, or in other words, f dash x gx plus f g dash x. Now these dashes are showing the respective differentiation or the derivative of the original function. So f dash x is just simply the derivative of fx. And similarly, g dash x is simply the derivative of gx. Let's see this question in action and it's going to be further clear. Just like in this one, if we carefully see, we see x squared sine x. In other words, we can identify our two functions, one of them being x squared, the other being sine x. So we just quickly identify them and write it like that, like how I mentioned, like f of x can be x squared, while g of x can be sine x. Doesn't matter what you choose, it's multiplication. And then you just start to say, what is f dash x? You find your f dash x first, which is you apply the differentiation on x squared, and it's gonna be 2x, and 2 minus 1 is just 1, so 2x. Similarly, g of x, I'm assuming you guys know what's the differentiation of sine, which is cos. So you just write cos x, and don't forget to put the dash because it's a derivative of sine. Now, remember the formula. It is f dash g plus f g dash. So what is fx in this one? It's 2x. And what is g? It's sine x. And then plus sign from the formula. What is fx? It's x squared. And what is g dash x? It's cos x. Now, if you want, you can further simplify if your question asks. Otherwise, leave it like this. It's more than fine. But if I just even simplify this, I get 2x sine x plus x squared cos x. And I think for me right now, this is more than good enough. But if your question says simplify to the fullest, just simplify. The other part being quotient rule. This thing is also having a formula like the top. You see a function being divided by another function, just like fx divided by gx. So whenever you see two functions being divided, not multiplied, then the formula turns out to be f dash g minus fg dash over, sorry, that's on me, over g squared. Or let me just put in the axis so we are not confused. fx, gx, and gx squared. So again, the ideology is still the same. Find your f, find your g, and then you just find your f dash, g dash, and plug it in the formula. So if we see the top is x squared plus 1. The bottom is x minus 3. So you just start simplifying it. How? Let's just look at it. Let's just say my fx is x squared plus 1. My gx is x minus 3. Now my f dash x would be 2x. The constant is always 0, so you just leave it like that. G of x would be the 1 drops in, and then just 1 minus 1, again 0, so it's going to be 1. And minus 3 turns out to be 0 directly. So it's this. Let me just put this dash so we are not confusing anything. Now, the formula again was f dash x gx minus fx g dash x. And this is all being divided with gx whole square. So now let's plug in the things which we found out. We say f dash x is 2x, gx is x minus 3, minus fx is simply x squared plus 1, and g dash x is 1 over gx squared. Gx is x minus 3, so it's going to be x minus 3 squared from the formula. Now, if you want, you can leave it like that, and if they ask you to expand, you may expand and just simplify to the fullest. It all depends on what question is being asked, because let me just simplify it to some extent for you guys. So the 2x we're going to multiply with x is going to be 2x squared minus 6x, and then minus from the formula is going to give you minus x squared minus 1 over x minus 3. Rest you can simplify yourself, and you will figure out that it can be simplified easily. It's just an algebraic expression. The other part being important one being called chain rule, because chain rule, people sometimes don't identify it's a chain rule, but the idea is simple. When you see a complicated expression in which you see there's a function, there's something going on, and within that function there's even more things going on, or in other words, a function inside a function, or outside function and inside function, just like in this case. So whenever you get something like this, the first thing you do, you take the derivative on the original function and make sure you don't touch the inside at all, just like in this one. Then you multiply the inside derivative of the function. Let me go through this again. I said that the outside function, which is f in this one, you take the derivative of outside, which is f dash. Now make sure when you're taking an outside derivative, the inside is not touched at all. So you just copy the inside as it is, which is gx. Then after you're done with this, you just find the g dash x, like the inside derivative, and multiply it to the answer. Let's look at an example, and it's going to be further clear. Now look at this. To all of you, it might look like a simple power rule or product rule or whatever, but this is indeed a chain rule, because you see that there's this thing. Let me just draw it down. This and this. So in this one, the outside is this bracket of 5, exponent 5, and the inside is the yellow part, which is 3x plus 1. So again, I said first you take the derivative of outside, which is this. What do? You see an exponent. You drop the exponent, 5, and then 5 minus 1, which is 4. Now, inside stays the same. Nothing changes in inside. And now, you just multiply it with the inside, which is the yellow part. What's the differentiation of yellow part? The differentiation of 3x plus 1 will be just 3 times 1, and its plus 1 derivative is 0. So it's going to be this. You further simplify, you get 5 times 3 is 15. 3x plus 1, 4. Maybe I went through really quick. Let's look another example. This question. Now again, you see two things. You see outside that there's this sign, and then within this sign, inside of the sign, there's a bracket, which is just saying x squared. So the outside is your sign, and the inside is your x squared. So again, first, you take the derivative of the outside. The differentiation or the derivative of sign is cos. Inside stays the same. It was x squared. It's still x squared. Now multiply it with the derivative of the inside, which is x squared, or the yellow part. So if you take the derivative of x squared, it's going to be 2x. And you just write it down. And if you want, you can further just multiply. It's going to be 2x cos square. Sorry, cos x squared. And that's it. Another question can be like this. Now in the start you might not even notice what's the outside, but if you look closely, you see the outside is this function. And with this root, the inside is x squared plus 4. So again, if you cannot highlight what roots are, you just always put them in exponents. How are you going to do that? You say x squared plus 4, 1 over 2, and d over dx is still the same. Now, you see 1 over 2. To apply the same thing as you applied here, the outside exponent, it just falls down. It's going to be half x squared plus 4 remains the same, and half minus 1 is minus 1 over 2. Now multiply this with the derivative of the inside. Now x squared becomes 2x, and 4 is just 0. So if you further simplify, this will come down eventually. So it's going to be 1 over 2 x squared plus 4, and it's going to be on the root. While the top will just become, it's going to multiply with 1, and it's going to be 2x. And that's it. That's the most simplified, or you can just cancel this. And that's the most simplified option you can go through. Pretty much these are all the rules, and let's just apply all of them in one situation. Now look at this one. Now if a person just doesn't know what to do, he's gonna start with anything. He might say, oh, let's just differentiate this, we're done. But no, you gotta look carefully what's going on in this one. If you see two things multiplied, can anybody see two things multiplied? I can, which is one of them being this part and the other being this part. So that's the majority, or the outer part you see that's happening in this situation. The yellow multiplied with the blue. It's two separate functions. So you know that they're being multiplied, you apply product rule. So let's just say you called your fx being 2x cubed minus 5x. And the g of x, you can just simply say it's x squared plus 4, and it's all an exponent 6. Now, if I ask you what's the f dash x, you just simply say 2x cubed is going to be 6, 3 times 2 is 6, x, and 3 minus 1 will give you 2, and minus 5 will just be minus 5, and that's it. And for the g dash x, now remember, g dash x is not just simply x squared plus 4. There's an outer function, and then there's an inner function, which is x squared plus 4. So you apply your chain rule on this one. You say it's going to be 6 drops, inside stays the same, and then you just say exponent 1 is 1, which is going to be 5, and now you multiply it with the differentiation of the inside, which is x squared plus 4 will become 2x, because 4 will become 0. And you further simplify, you get 2 times 6 to be 12x, x squared plus 4, exponent 5, and that's your d dash x. Now you got your g, you got your fx, you got your f dash x. You just apply the formula. What was the formula? Formula said f dash x gx plus fx g dash x. Now, as soon as you see this, you know which value to place at what. The f dash x is simply 6x squared minus 5, while gx is x squared plus 4 exponent 6. Similarly, plus sign from the formula, fx is just simply 2x cubed minus 5x, and the g dash x is 12x x squared plus 4, and it's gonna be exponent 5, like this. Now, if they ask you to simplify, be my guest, expand this. Expand as much as you can. Otherwise, you can leave it like this, and it's going to be more than enough for your answer. And that's how you find out derivatives. These are all the possible questions which can happen, because the only time they bamboozle a lot of people, like the common mistakes, they either give you chain rules, because the part about chain rules is people figure out it's something inside something. But what do? They take the differentiation of the outside, keep the inside same, and then they stop. But no, the full form of this is you take the derivative of the outside, inside remain the same, then you multiply it with the derivative of the inside. A lot of people miss out on that value, and then they start to lose marks. The last example that I showed you was the perfect example of a mixed question. So don't forget the inside derivative. Another thing is people think product rule is also used for addition. Like if you see this question, you see the two things are multiplied. A lot of people, whenever they see some addition, they think you have to apply product rule in this part D. But no, you don't. And my advice to you guys would be, if you get some negative exponents like in this one, like I got minus 1 over 2, or even if you get roots, you just make it in exponents, like fractions and stuff. It's better than roots. Roots are hard to deal. So yeah, before solving any derivatives, look at the structure, ask, is it a simple power, then use power rule, is it addition, subtraction, then differentiate term by term, one by one. If it's multiplication, then use product rule. If it is division, then use quotient rule. And if the function is inside of another function, you know what to use, which is chain rule. And if the pattern appears more and more, you know what to do. So my only advice to you would be, do not memorize anything. Just learn to recognize pattern. And that will happen once you start to revise and do more and more questions. And if you do this, you'll be on the right track. That's it for today's video. If this helped you understand how to choose the correct derivative rule, Make sure to like the video and share it with your friends or classmates or whoever is pretty much struggling with derivatives. Also, comment down below which math topics are you struggling with right now. It could be derivatives, integrals, trigonometry, algebra, or pretty much anything. I'll use your comments to decide and what to make in the next video. And that's it for this one. Thank you very much for watching, and I'll see you in the next one. Bye bye.